Presentation of dialogue on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family's legacy of helping build the great state of Idaho.
Coming up, what's it like to walk on the moon, to fly in outer space? Ask someone who's been there. Stay tuned, this special school time edition of Dialogue is next. Hello, I'm Joan Cartan-Hansen. Thank you for joining me here on Idaho Public Television and our broadcast on the World Wide Web. In 1961, President John F. Kennedy told the world that the United States would send a man to the moon. 12 people have walked on the lunar surface, a great scientific achievement, and Edgar Mitchel was one of those men. On January 31st, 1971, Edgar Mitchel, Alan Shepard, and Stu Roosa strapped in and headed for the moon. Apollo 14 was the first flight solely devoted to the scientific exploration of the moon. A film produced by NASA describes their landing on Fra Mauro, a rocky field near an ancient moon crater.
10 seconds to go. Okay, there's pitch over. Right there it is. Right on the money. Right on the money. That's beautiful. Right out the window, just like it.
There's Houston. You're go for landing.
Cone Crater, a major objective of this mission to Fra Mauro. A hole blasted in the moon's surface eons ago that could provide a scientific clue to the history of the moon, the Earth, and the solar system.
Right on schedule. Right on schedule now. Went by Cone Crater right outside to my right.
We think that the Fra Mauro area was formed from material thrown out by the impact that created the Imbrian Basin to the north. If this is the case, we could get samples torn out from as deep as 60 miles in the lunar crust. All in all, the Fra Mauro material should contain a great deal of new information about the early history of the moon, and thus help us to better understand the formation of our own Earth.
Shallows on the surface, and it's been a long way, but we're here.
4 minutes later, he was joined by Ed Mitchel.
This one is a long one.
Following the tradition of two previous missions, Shepard and Mitchel planted the flag in the lunar soil.
How's this, Bruce? Look okay?
Roger, that's a good sight.
While Roosa remained in the command module orbiting the moon, Mitchel and Shepard deployed scientific experiments on the surface.
After loading the lunar rickshaw, Mitchel began the journey to Cone Crater. Shepard adjusted the television camera, then hurried to join his partner.
Okay, Houston, we're headed just about toward the center of Cone Crater. Okay, point A, Al, is right. It's not quite in the valley, it's right beyond over here.
The men struggled to reach the top of the crater, but ran out of time and had to stop, just 65 feet short of the rim. But over the mission, they collected 95 pounds of moon rock and conducted a number of significant scientific experiments. Mitchel and Shepard then returned to the lunar module to begin the trip back to Earth.
Gas engine is armed. 6, 5, 4, 3, 2, 1, 0. We have ignition. What a liftoff. And liftoff. Roger, ignition.
149 hours after they left Earth, they performed the burn that broke them out of lunar orbit. During the coast to Earth, there would be time to catch up on sleep, relax, and do all the little things left undone. On February 9th, 1971, 9 days after they left Earth, the crew of Apollo 14 hit the atmosphere of their planet at a speed of over 24,000 miles per hour.
The three men splashed down in the ocean and returned safely home. And Dr. Edgar Mitchell joins us now in our Idaho Public Television Pocatello studio. Thank you, sir, for being here. I appreciate you joining us today.
Well, thank you for inviting me.
Well, I can't tell you what a thrill it's been just to go through the research material, because I remember all those the Apollo moon launches, and it was thrilling at the time, and it's thrilling to see it. What's it like for you to watch the video?
Ancient history. It's fine, of course.
Well, we've got lots of questions that people have, that students from all over Idaho have already faxed to us or done email. So let me ask a few of those questions to you, sir.
Go right ahead.
Coming from Mrs. Clark's second grade class in Arco Elementary, Justin Lord asked, how far can you jump on the moon?
Well, theoretically, one can jump 6 times as high as you can on Earth. But with a cumbersome pressure suit, and that spacesuit is like wearing 12 overcoats, you can't jump nearly as high as you think you can. So about 2 feet was, I think, the most I made.
And Ryan asked, why doesn't the moon have any air?
Primarily because it's such a small planet. And in the early formation of it, the oxygen and the gaseous molecules were very energetic, and in the reduced gravity, they all escaped into space. So all you have is a few little particles of gas that might outgas from soil, but it's so thin that it's virtually non-existent. And
see, from Mrs. I'm probably going to mispronounce this, so forgive me, Mrs. Trauberg, 4th grade class there in Arco. Colt Farmer asks, what does the moon feel like?
What does it feel like? Well, if you take its substance, its surface, it's like very, very fine talcum powder, but it's made of basalt rock, or lava rock, that's been pummeled and ground up by billions of years of meteor impact to a very, very fine pumice. Now, what does it feel like to us to be on it? It's kind of like being on a trampoline, where you can bounce up and down. The reduced gravity is very light, and allows you to bounce, which accounts for the bunny hop that some of us use to locomote, or the long sloping strides that others would use. You do feel light, even though we weighed 474 pounds Earth weight. On the moon, it only felt like about 72 or 3 pounds.
Now, before you went to the moon, you did some training at Craters of the Moon. Can you tell me about that?
Yes, we did. We trained on many different lava flows and volcanic, around volcanoes, including Craters of the Moon, because the lunar surface is primarily formed of volcanic materials. And the geologists who were training us wanted us to have sampling of volcanic materials from around the world, different types of volcanoes, different types of layering, and different types of activity. So we trained here at Craters of the Moon, we trained in Hawaii, we trained in the Pinacotes in Mexico, we trained in Iceland, and we also looked at a lot of craters created by meteor impact, like Meteor Crater in Arizona and the Reese Crater in Germany. So the idea was to get us well trained in volcanics and meteor impacts so that we could be the eyes of the geologists when we were on the moon, which they did a good job, and I believe we did a good job.
Are there any surfaces on the Earth that feel or could better replicate the moon?
Well, they're not precisely the same, because the processes on the moon were basically without water when those volcanic activity took place, and basically in a reduced atmosphere without any air pressure and reduced gravitation. But basically the chemicals are the same. It takes an expert geologist with a microscope and looking at the very fine structure of the materials to tell them different from Earth materials. But because we have weathering and we have wind and rain and more gravity-induced landslides in a different way than they do on the moon, it appears to the average eye, well, same and different, but if you look at the minerals, that it takes a geologist to really tell the difference.
Let me go to our first caller. It's Greg. You're at Holy Rosary School in Idaho Falls. Are you there, Greg?
Yeah.
Hi, Greg.
Hi.
You have to speak real loud for us. What's your question today?
it filled up with water when you guys landed in there? The thing that landed in the water.
I'm
sorry,
I couldn't hear. Could you say it one more time, Greg?
Why doesn't it fill up with water when you fall into the ocean?
When the capsule fell into the ocean, why didn't it fill up with water?
Yeah.
Okay.
Oh, well, because...
Good question, thank you.
Good question. It was sealed from the air, therefore it was, and sealed from space, therefore it was also sealed from water. And the Navy divers jumped in and put a flotation collar around us so that it would stabilize us and we would float like a boat. And then they put a raft beside that, and that was all before we opened the hatch. When we opened the hatch, then we had a flotation collar and a raft that we could get into, and since the seas were fairly calm, no water splashed into the spacecraft.
Okay, let's go to Joanne here in Boise.
How do they get water up there to take a bath?
Okay.
How do we get water to take a bath? Well, we didn't do much bathing on the flight, but in the command module, we carried hydrogen and oxygen, and liquid hydrogen, liquid oxygen, and by combining those two, we got the products of electricity for our spacecraft and water to drink and to take a sponge bath in. But that's the best we could do. We had sponge baths and wet wipes, and we didn't really have any good baths at that time.
Well, you weren't really up in space too long.
No, we were only there 9 days, so we could sponge off. I'll have to admit, according to the frogmen, the space capsule was a little bit rank when we returned after 9 days.
Questions from Mrs. Goebbels, I think I'd say, third grade class, Central Primary School in St. Anthony. They faxed this a whole bunch of questions. One of them is, can girls go into the space or space program?
Oh yes, there are many ladies in the current shuttle program, many female astronauts, and they do a wonderful job.
Including Barbara Morgan, who
Yes.
is an Idahoan, who's our teacher in space program. And another question was, what does it feel like to be weightless?
That's a wonderful feeling, and the best way for you to experience it is in the swimming pool. If you had a scuba tank and you get underwater with a scuba tank, that's how many astronauts today practice feeling weightless, is get in and just float under the water with oxygen with a scuba system, and that's very close to being weightless. It's a wonderful feeling.
Now, there's no up or down per se in space.
No,
how
because
do you orient yourself?
Well, that's a little more difficult. Since there's no gravitation vector, or the gravitation vector is acting on the spacecraft the same as it is on you, so you don't feel down in the spacecraft. At night, or if you close your eyes and don't have orientation, it can be very, very confusing. You have to open your eyes, you have to see where you are, and you have to orient yourself with regard to, well, you're just floating around, so you orient yourself with holding on or being strapped down or tied down. But if you just float around, you bounce off everything. Everything you touch, you'll bounce away from. It's interesting, but can be confusing till you get acclimatized to it.
How long did it take you to get used to it?
Oh, generally an hour or so. Once you're in space and know what to expect, it doesn't take long.
Rachel Sterling, she's a third grader at Nez Perce Elementary, wrote and asked, what's the hardest thing to do in space?
Hardest thing to do in space? Well, I'll have to think about that one for a moment. I guess the hardest thing to do is to make sure you can come back home okay. The navigation problems, the re-entry is a very difficult problem, very precise, precise maneuvering and control is required. Getting back home and staying alive is what you're there all about.
Yeah. Kayla Baker asks, is it lonely in space?
No, because we had our partners. We were very oriented toward accomplishing our mission. Now, if you didn't have a mission to accomplish and you were there by yourself, I can imagine it would get very lonely in a short period of time. And we were always in communication with the home base in Houston. They were always keeping us updated on what was going on. So we didn't really have time to get lonely.
Let me ask you really quickly about the scientific experiments that you conducted while you were on the moon. What sort of things did you do?
Well, we collected samples for the geologist, about 98 pounds of samples. We, right in what you're seeing right now, we are setting up a telemetry station, nuclear-powered telemetry station. There it is. That's a little thermonuclear generator. And attached to that are, that's a telemetry station you see there. Attached to that are different experiments. I can't remember what that one is. That may be
I think that's a seismograph.
Seismograph. Those are particle experiments, others that are particle experiments to capture the solar wind, to capture particles coming in from space. I also set up a seismic experiment in which I used a thumper. It had shotgun shells in it to thump the lunar surface and to resonate a seismic network that did seismic work. Then we took pictures, we documented all of our samples. We had a very busy 10 hours on the moon.
What do you think was the most important thing that science learned from your mission?
Well, it has to integrate into all the other missions. What we're really looking for at that point was the age of the moon, the age of the solar system. What could we learn from our moon that would tell us about our Earth, since many of the ancient clues were washed away by wind and rain and on Earth, whereas on the moon, if we could get to them, they would be pristine and preserved for billions of years. And so it helped us understand the processes of our solar system and thereby the processes of the universe as a whole, and help us to date our solar system much more accurately.
Let me go back to our phones. We've got Jimmy in Boise. Jimmy?
Hello, my name is Jim. Sorry.
That's okay.
I said it. My question is, what is the heat shield made out of?
The heat shield on the...
What is the heat shield made?
What is the heat shield made out of?
Well, I won't give you a chemical formulation for it, but it's a resin that ablated away, in other words, burned away. It would melt as we came back in the Earth's atmosphere, and the heat of impact as we came in, as around 25,000 miles per hour, would start to burn away this resin, and it would allow us to control the temperature. That, combined with the air conditioning system in the spacecraft, allowed us to come in without being fried.
Okay, and let's see, Brett in Blackfoot. Brett?
I'm wondering what it's like to be in a rocket.
What does it feel like to take off in a rocket?
No, what it's like to be like in a rocket.
To live in a rocket, okay.
To be in a rocket.
To be in a rocket, okay.
Well, when you're on the rocket itself and it's thrusting into space, it's like if you've been in a subway, rocking and rolling and pushing, you're being pushed very hard into Earth orbit, so you're feeling the gravitation. Just like when you're on a spinning wheel at the circus or at the carnival, or when your dad is driving around a sharp corner at high speed in your automobile, you get pushed against the wall. Well, you get pushed back against the seat in a rocket. Then when you get into space and the engines stop, you're in zero gravity. In other words, you're floating, and there's no forces on you at that point. So you're floating around very nicely. As was said earlier, there's no up nor down, east nor west. You're just floating or free falling through space, just like a rock. If you throw a rock into the air, it's in free fall. It goes in a trajectory, it goes up and comes down. But it doesn't feel anything. It is just in free fall. And that's what being in a space capsule in space is like.
So, as in a car, you'd feel pressure as you move forward, but you don't have that same forward feedback as you're in space.
Right.
Okay, well, let's see. Victoria Carroll in 3rd grade Nez Perce Elementary wrote and asked, do you have a favorite planet or a favorite star?
Oh, the favorite planet is the one we're on right now, and the favorite star is the one that provides all of our energy. However, I got to name our lunar landing module, and I named it Antares because that's the brightest star in the constellation Scorpio, and the star that we took a final sighting on before we started down to the lunar surface.
Tasha Patterson wrote to ask, what do you eat and drink in space?
At that time, freeze foods were being engineered to, in large measure, to help us with spaceflight foods. So we had a lot of freeze foods, frozen, freeze-dried soup, freeze-dried coffee, freeze-dried this and that. We also had some sandwiches. We had tuna fish sandwiches. I think we had some peanut butter and jelly sandwiches. But I'll have to admit, it wasn't like Mama's home cooking. It was good to get back home.
Sierra Dye, who's in 4th grade, asked, do you think people will ever go to the planets Neptune, Uranus, and Saturn?
I'm sure that in the next century, we will go to the vicinity of the large planets. I'm not sure that they're suitable for landing, but we may very well land on some of the moons of those planets. And it's my expectation that we will go back to our moon sometime in the future and put a scientific colony there for a while, scientific observation station. Mars will be likely our next manned mission objective. But before the century is out, I'm reasonably certain we will go much deeper into our own solar system. And perhaps by the end of the century or next century, if we learn enough how our universe is put together, we might even go deeper into our own galaxy. We might even realize the Star Trek sort of idea.
In your book, you wrote that you at one time hoped to man a mission to Mars.
Yes, we were idealistic back in the 60s when I was doing my doctoral work. And I was really hoping that once we started and went to the moon, we'd go right on and go to Mars. I wrote my doctoral thesis on a navigation plan for low-thrust engines to go to Mars, and based it around the near conjunction of 1982. But it so happened it didn't work that way.
Well, let's go to let's see, Casey in Lewiston. Casey?
Is it true that you found a planet behind Pluto?
A what, please?
Is there a planet behind Pluto?
Yeah.
I don't think so. I am not an astronomer, but I don't believe we found anything like that. There are indeed, there has been looking, and there are some wobbles in the planets out there, but I don't believe that's been confirmed. Maybe I stand corrected if I haven't checked into it recently, but I don't believe so.
And let's try Austin in Coeur d'Alene.
What does the sun look like from out there?
Okay.
What does the sun look like? It looks very much like it does from Earth, only brighter, and you certainly can't look at it from out in space without glasses or without a lens of some sort, because it would burn your eyes just as it does here. But because of the lack of atmosphere, with the proper equipment, we can get a little bit better look at the sun and its corona and some of the processes than you can on Earth.
Let's try a question from Danny in Greenhurst.
How does it feel when you take off?
When you take off, it's, as I said, kind of like a vertical subway. You're being pushed from behind. You're lying in the couch. You're being pushed on your back up to about 4G, 4 times your weight. And then the first stage quits. We call that the train wreck because the giant Saturn V rocket has been compressed like a spring. And when the engines stop, the first stage stops, the spring releases and you kind of get bumped in the back as the vibratory motion takes place. And then the second stage cuts in and throws you back in the seat again. So that portion, a couple of minutes into the flight, is a little bit rough for a few seconds, but it's really not that bad. We were expecting it.
The moon rocks that you collected, did they give us some I realized that when we first went to the moon, we didn't know exactly how the moon was shaped and how it was formed. Yep. Did those moon rocks tell us what the moon is?
All of the substances that have been returned, many of them are still in storage, waiting for geologists to think of new experiments. But yes, we're having a pretty good. The geologists and the lunar geologists have a very good feel for how the moon is formed, what its basic substances and processes are, and are waiting additional experiments to try on it, bright young people to come along and propose different experiments. And there's I think the primary theory now, I don't follow lunar geology that closely. I think the primary theory is that the Earth and Moon both formed about the same time, but they collided, and that there should be a little mix of material between the two.
Let's do one real quick call. Nathan at Star Elementary.
Yep.
And what's your question, Nathan?
Is there ice on the moon?
Is there ice on the moon?
There seems to be the recent developments, a recent spacecraft, have led some of the scientists to believe that both at the north and south pole of the moon, which does not get a lot of sunlight because it's not in the right position, that they think they've now found quite a bit of ice on the moon that might possibly be used as water if we were to set a scientific colony there. So many of the scientists are very excited about the fact there might be some water or some ice on the moon.
What advice would you give to someone who's listening today who thinks that maybe they want to be an astronaut someday?
Be in good health, keep your health, exercise, keep your body strong, get all the education you can, find a career that excites you, that you can really be passionate about, and that would be in the sciences that NASA could use as a for space exploration.
Do you have to go into the Army or be an Air Force?
Oh, no. In the early days, the most qualified pilots did come out of the Air Force and Navy test pilot ranks. But today, there are many careers in flight in NASA that are scientists, that are specialists, that are technical people, that are not pilots.
What one thing do you tell people when they ask you, what was it like to walk on the moon?
Wonderful. Yeah, I'm an explorer. That's what I've done most of my life, to explore the unknown, whether it be in aviation in the early days as a test pilot, then as an astronaut, later as a scientist looking at the nature of cosmology and how mind and how we evolved, living substance evolved in the universe. So that's exploration. That's what I've done my entire life.
Well, thank you, sir, for joining us. We've run out of time. If you'd like to learn more about Dr. Mitchell, you can click on to the Idaho Public Television website. We have a fairly extensive website. There's our address, idahoptv.org. This program is also being simulcast on the web and will be stored there, so if you want to watch this program, you can do that again. You can also go to your library and learn more about it. There's lots to do. You can also, if you want to learn more, tune in this Thursday evening at 8:30. Dr. Mitchell will be on again on our regular dialogue program. So that's our show for today. Thank you, sir. I appreciate you joining us there in Pocatello.
It's been a pleasure. Thank you.
And I will see you Thursday night.
You will indeed.
And thank you for joining us, and hope you have a good day.
Presentation of dialogue on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family's legacy of helping build the great state of Idaho. Dialogue is a production of Idaho Public Television.
To purchase a videotape of this program, please contact Idaho Public Television at 1-800-543-6868.